So hello and welcome everyone. My name is Jay Dalsaniya, and in this video we are going to solve the problem of the day, and that is spirally traversing a matrix. Okay. So this question is quite interesting to solve, and here we have to observe some important things like if we have to print some kind of pattern in some given data, then how we can think about those patterns. So it is similar to printing pattern kind of questions that we used to do before starting DSA, right? In order to understand the loops in a better manner. So this is the same the effort that you need to apply over here in order to solve this question. Okay, so if you are really enjoying this video solutions, then do hit the like button and shut down your reviews or views or write down your approaches in the comment section below, and it would be good to read down the comments as well. Okay, so without wasting any further time, let's start the video. So the name of the question is spirally traversing a matrix. So in this, you are given a rectangular matrix, and your task is to return an array while traversing the matrix in a spiral form. Okay, so spiral is in this manner, right? So let's try to understand. Let's take one example and let's see what can be done. So here they are saying that the matrix that will be given to you is not always going to be a square matrix. It can be a rectangular matrix as well, and we know that a rectangle can be a square, but a square cannot be a rectangle, right? So there can be a rectangle as well as there can be a square given in the matrix. Okay, so you are supposed to print in the spiral form, and what does a spiral look like? So spiral looks in something similar to this. Okay, so here if I have taken this example, let's say this is my matrix given in the input, and the dimensions of this matrix are n cross n, and here it is 5 cross 5, 5 rows and 5 columns are there. So if I want to print it in the spiral form, so I'll be starting in this manner, so it will be printed in this format. So let's say to see, so first of all the first row will be printed, so I'll be printing 1 2 3 4 5, and then this column. So let me start, so from here to here, then from here to here, so it will be 10 15, so I'll be saying 10 15 20 25, and then from here to here, so that would be 24 23 22 21. So I'm writing down in a row format because it might take much space if I write down in a particular single row. And now if I continue, so I'll be having 16 11 6. Again if I continue, I'll be having 7 8 9. Again if I continue, I'll be having 14 and 19. If I continue again, so I'll be having 18 and 17. And if I continue, I'll be having 12 here, and then over here I'll be having 13. So this is the output list that you are supposed to return. This is a single list. Okay, and in the output that single list will be printed, and it will be checked whether this is a spiral traversing or not. Okay, so I hope you got an idea what we are supposed to do. We are given a rectangular matrix, and we are supposed to print the traversal by traversing the matrix in a spiral format. So that's the question. Now, how to think about the approach of this question? Let's try to brainstorm a little bit on how to think about the approach. Okay, so let's see. So by observing the pattern, that is spiral pattern, you might have observed that I can see something like, let's say I am supposed to, when I was starting the spiral, you observed that this first row elements were inserted in the output, right? So first row elements were printed, then this last column elements were printed, then this last row elements, then again the first row, then again here the row changes. Now here I will be using the second row. Now here second last column, here second last row, here the second row, right? And then again the spiral is break down into a smaller square. So here if you can observe, there is an outer square available, then there will be an inner square, then there will be an inner square, then there will be an inner square. So in this manner the spiral jumps from the outer square to the innermost square. So here in order to observe the pattern, so here in order to observe the spiral pattern, like how it basically prints the output, if we think about the given matrix in terms of multiple squares, right, overlapping each other. So here I have drawn the outermost square for the given matrix. For this matrix, this is the outermost square, and these are the elements over here mentioned along with the indexes over here. Then there will be this innermost square. So 7 8 9, this basically forms the inner square, right? And then there will be one more square available that contains only a single element. Okay, so there are 4 different directions in which we should print the output. So first direction is from left to right, this much, right? So for this square, what will be the output for the first direction? Let's see. So we will be having 1 2 3 4 and 5. So we'll be having this many elements, right, from here to here. Now from top to bottom. So the second traversal is from top to bottom. So here you can see the last row, basically the last column, all the elements will not be printed. One element is basically shared between the first row and the last column, right? So this element will either be included in the first row whenever you print the output for the first row, or it will be included when you print the output for the last column. Not always, like not in both the cases it will be included, right? So now for the last column, I have 10, 15, 20 and 25. So 10, 15, 20 and 25. Now it will be from right to left. Then I will be traversing from right to left. So I'll be having 24, 23, 22 and 21. Then I'll be traversing from bottom to top. So now when I traverse from bottom to top, you can see this all elements are not included, right? So first was the part of the first row, and this last element was already the part of our previous traversal over here, that was from right to left. So only this many elements are included. Now the elements are 16, 11 and 6. Okay, so what was the number? I just messed up. Okay, so it was 11 over here. Let me write down in a clear manner. Okay, so 16, 11 and 6. So that will be printed. So here you will be having 16, 11 and 6. So first we are observing what is the pattern that we are supposed to follow. Okay, now if we jump to the inner square, we'll be having this square. So for this left to right, 7, 8, 9 will be printed. So 7, 8 and 9. Then top to bottom, 14 and 19 will be printed. So I'll be having 14 and 19. Then right to left, I will be having 18 and 17. Then bottom to top, here I am having only a single element, that is 12. Okay, so moving on forward, the inner square of it, so we will be having only one element, that is 13. So only this element, that is 13, will be there from left to right traversal. So here will be not having this many traversals, that is top to bottom, right to left and bottom to top. These traversals are not there. Okay, so now what did we observe over here? So we observed that when I was doing a traversal, we know that there are multiple elements that are being shared among this 4 traversal, right? So here I observed then that in this square, when I did the traversal from left to right, 5 elements were there from left to right. Then I'll be having only 4 elements because one was shared, right? So I'll be having 4 elements. Then here from right to left, again 4 elements because 25 was a shared element. Now when I see bottom to top, I have only 3 elements. Okay, so I can see the number of elements are not always constant in this traversal. Okay, fine. So here what do we see? Here we see 3 elements in the first traversal, 2 elements over here, 2 elements over here and 1 element over here. And here it is little bit different. I have only 1 element over here. Okay, so now we have divided this entire thing that we have some squares and they are basically overlapping squares. You can call them overlapping or something like that. So first of all, if we observe that when we were traversing this from left to right, you can see that there was some range, right? So the range was that we were traversing from the 0th column to the last column for the traversal, that is from left to right. Then when we started the traversal, that was from top to bottom, we did not include the 0th row because 0th row was already covered over. It was already covered in the previous traversal. So we started from the row number 1 over here and then we proceeded till the last row, that was over here, that is 4th row number, right? Okay, so now when we started the traversal from right to left, you can observe that we were not starting from the last column because last column was already taken care in the previous traversal. So we started by last column plus 1 element. So we started from here 24 and we went to the starting of our row number, starting of our column number. So column was starting from 0th column, right? So we went till there. Now when we did the traversal from bottom to top, you can see that we did not start from the last row and we went to the first row. No, we started from the second last row and we went to the second row, not the first one, because here you can see the last row was already traversed in the previous traversal. And see, in any traversal, the first element will be there, no? In bottom to top, the first element will be 21, but this 21 was already traversed in the previous traversal, that was from right to left. So this element will be excluded. Now here there is an exception because here generally what happens, it takes place from the second last element to the first element, but this first element was already taken care in the left to right. So here you can see 16, 11 and 6, only those elements are there. Now if I explain you with the second square, let's see. So imagine that there is a starting value, there is a range of row and there is a range of column. So the range of row is from 1 से लेके 3 in the second square and the range of column is from, let's say, 1 से लेके 3 as well. Both of them are having row equals to, let's say, row is from 1 and column also starts from 1 and it goes till 3, both of them inclusive. Okay, so now here you observe. So what happens when I do the traversal from right to left? You can see it starts from the range of the column is from 1 से लेके 3. So it starts from the column 1 and it goes to the range. So it covers the entire range of the column. Okay. Now when I do the traversal from, that is from bottom to top, you can see the first element of this traversal was already traversed. First element of top to bottom was already traversed in left to right. So we start from the second element. Okay. So second element. So we are starting from row number 2, not from row 1. We start by +1 row number. So we start from row number 2 and we go till 3. So we start from here and we go to the last, that is the limit of the row. Okay, then when we start the traversal for right to left, the first element was already taken care in the previous traversal. So we start with +1 element. So we start with what column? So we start with column 2 and we go till column starting. So here we don't include all the columns from 1 se leke 3. We traverse in right to left direction, and so we start from 3 minus 1, that is 2, and go till the first element. And now when we go till bottom to top, the last traversal, we can see the first element of bottom to top was already traversed in the previous traversal. Okay, and the last element of bottom to top was also traversed in the left to right. So we have only single element. And what elements, what range of element? So here you can see the row number is changing. So row number is changing, but the last row will not be included. So 3 minus 1, 2 will be included, and also the first element, that is first row, is also not included. So 2 se leke 2 elements are included as the row number for this traversal. Okay, so from this, what idea we are getting? We are getting an idea that for any square, we need to keep the track of what is the range of row and what is the range of column. So if we keep the track of row and column for every square that we have in our spiral, then it will be very easy to print this 4 patterns. Okay, and there might be a case where you will be having a square and that square might not be having the all the 4 traversal. It might not have all 4 traversal. It might have only 2 traversal or might have 3 traversal only. Okay, so we need to handle that part as well. So don't worry, I'll explain each and every part how we have concluded that what should be the range of traversing from left to right, top to bottom, and all of these things while explaining the traversal. Okay, so let's start the explanation part and let's understand how to frame the algorithm. Okay, so here, so again I have written down, I have separated this entire thing. Okay, so here what I have done, I have written down that in the outermost square how many rows are there. I can see 5 rows are there and 5 columns are there, right? Now in the inner square I can see how many rows and how many columns. I can see 3 rows are there and 3 columns are there. So I have written down that number. Here also how many rows and how many columns? 1. So here you can see row and column number was 5, then it was reduced by 2 values. So I got row and column number as 3, then again it will be reduced by 2 values. So I'll be getting row and column as 1. So total number of rows and column, I'm suggesting that thing. Okay, so let's start and let's try to figure out that what will be the 4 traversal for this first square. Okay, and let's try to frame the algorithm. Okay, so as I mentioned while starting, so I said that we need some starting and the ending of the row and column. So right, so we need that what is the range of the row and what is the range of our column. So what for that, what I will be doing, I will be taking the total number of rows. So total number of row is what? 5, and what is the total number of column? Is also 5. So this is the total number of rows and columns, and what I will do, I'll take the starting range and I'll call r equals to 0 and column equals to 0. So here I am saying that the range of row is from what? It is from r se leke row, where this row is not included, and column, the range for column is from c se leke col, where this is not inclusive. Okay, so as I mentioned, we need the range of row and column. So these are the 4 variables that I have taken, and why I have not taken 4 instead of 5. Okay, so there is a reason of it, so I'll explain afterwards. Okay, so while writing the code you will get to know. So now let's try to frame all this traversal. So first traversal is from left se leke right. So we know that this will be traverse, right? So here what is the range of row? Let's say row is starting from where to where? I can see that row is remaining constant, 0th row, and column is having a range from 0 se leke the last element, that is 4. This is the range. So here you can see that you need to have find out the row number, and you need to iterate over the number of columns. So I can use a for loop, and I can write it down something like this. Let's say for, I'll use the variable j to denote whenever I am having a loop that is iterating over column. So I'll say for j equals to 0. But here you can see, don't use this static elements. Okay, don't use any kind of constant. Use the variables that you have used over here. So what this RNC denote? So the meaning of RNC, they denote the starting of row and column respectively, and this denotes the ending of row and column respectively. Okay, so here you can see column is starting from c equals to 0 and it is going till 4. 4 is the end, so it will go from c equals to 0 and it will go till column minus 1. So I'll start the range from j equals to c to j is less than column. Okay, not inclusive column. So it is iterating over this entire range. So I've written this range. Okay, so I'll be adding that. Let's say you have created an answer list. So let's say inside that list, I will be adding this value. So I'll say, what is the row number? Row number remains constant. So first row. So that is r equals to 0. I'll use this as my row number. So I'll say r, and the column number changes. So I'll be using that as j. Okay, fine. Now let's move forward. Now moving on forward. So next traversal is from where? Say it is from top से लेके bottom. Okay, so here what is the traversal? So the traversal looks something like this. It starts from here and it goes till over here. So it starts from the row number changes. It starts from 1 and it goes till 4. So row is from 1 से लेके 4. And what about the column number? Column number is the last column. If you can see, it is column number 4. So here you can see that column number, you need to find what is the column number, and you need to find what is the row number. So the row number is changing every time, so I can use a loop over the row number. So I'll say for j equals to 1, but I should not use 1. I know that the first element of this traversal will be covered in the previous traversal. Okay, so the first element of this top to bottom is the element 5, but it is already covered in the previous traversal. So I should use the next element, that is I should start from 10. Now how to get this value? So here you can see it is having row number 1. And what happened when you did the traversal from left se leke right? So you know that you have traversed this entire row. That means the starting row, if your range is r equals to 0, then this entire thing has been traversed, right? So you should basically increment the value of r so that you will get an idea that the second traversal should start from the row number 1. So here after completing the traversal left to right, I'll use the increment on the starting position of the row number, that is over this range. I'll increment this range and I'll increment by +1. Okay, so now I can start the iteration. So I'll say j equals to r to j is less than last row. What is the last row? It is row. The variable row indicates the last position, right? So it will go till the end of the row. So I'll use till the end of the row, and I will add that variable. I will add the elements inside my answer. So I'll say array of the row changes, right? So for row, I'll use the loop variable as I, not j. Okay, so we can differentiate easily. Now I will start with the element I, and what is the column number? So I can see column number is the last column. So what is the range of the column in any square? I can see it is from column se leke column variable, c se leke call variable. So call variable is saying 5, right? So I'll say it is call minus 1. So I'll get the last column. Okay, so that's it. Top to bottom is completed. Now moving on forward. So the third point is from right to left traversal. So in right to left traversal, we are talking about which traversal? We are talking about this traversal, right to left. Okay, so we know that the first element of this traversal is already covered in the previous traversal, that was 25, was already covered, right? So this right to left traversal starts from the second last column. You can see the last column is over here, but it starts from the second last column. And what does the end position indicate? Like which variable indicates the end position of column? So column is from C se leke call. So call variable indicates the end of the column. So this variable should be decremented from 5 se leke 4. So I'll get the last column position. Okay, so that is the part we'll be seeing in a few minutes later. Okay, so first of all, let's write down what is the range of row in this. So row remains constant and row is what? 4. And what about the column? Column starts from 3 and it goes till the position 0. Right? So 3, 2, 1 and 0. So now I can see that I need to iterate over the columns. So I'll use j equals to 3. So how will I get this? So I already said that the last element or the first element of this traversal is already covered in the previous one, right? And it was present at which column? It was present at the column number 4. So I should start with column number 3. Okay. So here we can see this column is already printed by some traversal. So I don't need this column. So end position of column range should be decremented. So I will be jumping from 4 to 3. So I'll decrement this value of column before end into before jumping to this loop. So I'll say it is now 4. That means 4 columns will be there. Okay, so I'll use that before coming to this traversal. So I'll say column minus. Now I can start the iteration. So I'll start from j equals to column to j is what? Greater than or equal to 0. Now what is this 0? 0 is the starting of this range, starting of the column. So column starting is represented by this variable c. So I'll use this variable c and not the constant 0. Now I'll say I'll add this value to the answer dot add array of the row remains constant. Row is what? The last row. So what is the range of this row? Row is from R se leke row variable. So row variable is saying 5. So 5 is the total number of elements. So I'll say row minus 1 is the last row. So I'll say row minus 1 and I'll say the iteration over column is done by the variable j. Okay, now the fourth and the last traversal, that is from bottom to top. So here also what will be the range? But before that, let's see what are the elements. So it starts from here se leke here. So the first element of this traversal is already covered in the previous one, right? So 21 was already covered. Now here this is 1 1 11. Okay, so now I can see the range of row starts from 3 and it goes till 1. Okay, so I will say the range of row starts from 3 and it goes till 1. And what about the column? Column is the first column over here. Column is the first column. So I can see the range of row is from 3 se leke 1. This is not the complete range of row. The complete range of row is from 0 se leke 4. Okay, so I can see the range of row has been reduced down by some position, and the starting of the row has also been reduced. So this R was incremented by 1 and this R should be decremented by 1. So this value of a row, if it is decremented by 1, I will get this range, that is from 1 se leke 3. So this R was already incremented by 1 by some calculation, but this row was not decremented by 1. So I'll decrement this row value by 1 before coming to this traversal. So I'll say row equals to 4. So here before coming to this traversal, I'll say row minus minus. Okay, so now I can use the loop over the row. So I'll say for I equals to row se leke to what do we have here? We have I should be greater than or equal to the starting of the row. So starting of the row is indicated by the variable R. So it is R. So we'll be having 1 over here. So I'll use I is greater than or equal to R. And I'll add this value inside my answer dot add array of what is the row. Row is indicated by I, and what is the column. So column is constant over here. Column is the first column or the first column of our column range. So column range is from C se leke col. So it starts from the variable C. So I'll use this variable C over here. So I'll use the variable C in this scenario. And that's it. But now here, what to do? So after doing this thing, what should I do? What variable should be incremented or decremented? So here if you see what happens, now after this, we'll be going to the inner square. So when you go to the inner square, you know that what we were supposed to do. We were supposed to increment the value of R by +1, row, that is the highest or the ending of the row, by -1, and this column C value should be incremented by +1 because this first column is already done by this outer square. So after the last traversal, this value of C should be incremented as well as the value of the column should be decremented by 1 because you are moving, the square size keeps on reducing. First this will be the square, then you will be having a smaller square, then a smaller square. So this range will get incremented by 1 and this row, that is the ending of the row, will reduce by 1, and similarly for column. So this thing is done, this thing is done, this thing is done. Only remaining part is this column variable starting position. So I'll say C++. So that will make some sense. So now let's try to basically complete this entire solution. So we have written a general solution and this is the entire algorithm. So this will be working for each and every row and column or for each and every square, and you can do some more dry run on it So if I keep on doing the dry run, this might take much amount of time, but I really hope you understood how we figured out this entire algorithm. Okay, now how many times this entire thing should be iterated? Okay, so you can see what is the starting position of row. It is indicated by R. So if your R is less than row, similarly your starting position of column is indicated by C, and if your C is less than column, then if these conditions are fulfilled, then keep on doing this thing, apply this logic. Okay, now let's try to basically see the implementation part, but there will be a minor change over here. I'll explain what is that minor change afterwards. So let's try to see the implementation of it. So here is the entire implementation I have implemented in Java, but you can take the reference of the algorithm that I have showed you. Okay, so here this is the list that I will be using to store the answer. Now this is the range, so I have calculated how many total rows and how many total columns will be there. So a row indicates the ending of the range of row in any square. Okay, and this indicates the starting of any row and column in any square. So while my R is less than row and C is less than column, so this is left to right traversal. So exactly similar to what we wrote down inside our uh, algorithm. This entire J is equal to C2, J is less than column, J is equal to C2, J is less than column, and matrix of this element, and then increment the row. So increment the starting of the row range. Then this is from top से लेके bottom. So here I'll be starting from I equals to R, and I'll go till I is less than row, and the element is an array of I and column of col -1. So here this is the same thing. Then I'll be reducing the ending of the column. So column minus minus. Then over here, so this third point is traversing right to left. So over here, what I have done, similarly, what we did over here, J is equal to column -1 and J is less greater than or equal to C. So here I just forgot to mention it will be column -1, because column indicates a value that should not be taken, right? So column -1 and J is greater than or equal to C. So here you can see the same thing, column -1, J is greater than or equal to C, and here something AND condition is used. I'll explain what is that AND condition afterward, but let's see the rest of the all things remain same, and row minus minus, and then I equals to row, I is greater than or equal to R. So here you can see the last traversal equals to row -1. Here also row -1 I forgot to mention, that would be row -1, because this row indicates that there are 5 rows and this column indicates there are column 5 rows, but indexes of row will be from 0 se leke 4 only. So, and at the end I have incremented the value of C++, and then I have written the answer list. So that's it. So what about this R is less than row and C is less than column? So remember this test case, this inner square, you can see over here, this last inner square was not having this second, third and fourth traversal. So in that kind of scenario, when you don't have second, third and fourth traversal, you are not supposed to iterate this right to left and bottom to top. If you do so, you will be printing some repetitive numbers and that will lead you to wrong answer. So that's why I have used a check. So you can use that check at this condition as well when you do the traversal from top to bottom. But I don't think that's required, because the first element of any traversal will already be traversed in the previous one. So in the top to bottom also, you don't need it. But in this third and fourth, it's required. And yeah, so that was it. So now let's try to click on submit button and let's solve this, right? And we can see that the problem has been successfully submitted. So this was a pretty lengthy explanation of how to print the matrix in a spiral manner. So if we see like what will be the time and space complexity of this. So in matrix quotient, whenever we have any kind of traversal, the time complexity is equivalent to how many elements. So here also we are doing the same thing. We are not iterating over any elements multiple times. So order of n square or r into c will be your time and space, because space is occupied by this answer list. So that's the reason. Okay, so that was it for in this video. I would recommend everyone to do once a dry run of this entire solution, so you'll get to know what entire explanation is all about. So that was it for in this video. I will be seeing you in the next video. Till then, keep coding and keep on watching Geeks for Geeks practice channel. Thank you everyone. Thank you for watching.